So again, we're talking about coordinate axes in trigonometry and sine rule. You'll be able to understand sine and cosine in terms of the unit circle, as well as learning one way, or actually refreshing your memory because you did this back in your previous class, on how to solve non-right triangles using the sine. Okay? Okay, so to start off, again, the coordinate axes, when you deal with trigonometry, it's more of an introduction on some of the things that you'll experience in the next unit, which talks about circular functions. However, it is introduced here because we're talking about the basics of trigonometry, sine and cosine. So if you have an angle, theta, and it has its vertex at the origin, a positive angle is always measured in the counterclockwise direction from the x-axis. Okay? So if you're given an angle or given a right triangle, the angle is measured from the x-axis heading in the counterclockwise direction. Okay? Then wherever that hypotenuse is, we represent technically the radius amongst this unit circle. And to find out your adjacent side and your opposite side, it basically be the cosine of that respective angle and then the sine of that respective angle. Okay? Those will also represent the x and y coordinates of said point that's located in the unit circle. So again, using that, you can determine the size of your angle, okay, depending on where that point is located. You can do some SOHCAHTOA, et cetera, or you can also find that point, that location, okay, because x is the cosine of your angle and y is the sine of your angle, all right? So we're going to look at an example. We're going to find the coordinates of D. Okay, we're actually going to find the coordinates of D. This is a portion of the unit circle. Let's not draw the whole thing, just for that little bit. All right. That 59 degrees is, of course, starting from the positive x-axis, heading in a counterclockwise direction. That's where the 59 degrees comes from. And then to find the coordinates of D, all we do is use what, you think? How do you find that x value? Cosine. Use cosine of the angle, so cosine of 59 degrees. And then to find the y value, the sine of that angle, sine of 59 degrees. All right? Go to our calculator. We'll type that in. We'll get an answer. Of course, how are we rounding? Three significant figures. Now what you should notice is that D, the coordinates of D should be less than 1 for both the x and the y coordinate, because if we're within this unit circle, the highest we can go is to a positive 1, that's where it crosses at the y-axis, and then the furthest over we can go is a positive 1 along our x-axis. So, what is cosine of 59 degrees? 0.515, and the sine of 59 degrees is 0.857. Simple enough, right? Okay? Boom. Moving forward. Moving forward. Take a look at this. Find the value of theta to the nearest degree. Okay? We're going to find the value of this angle, knowing that P is the point 0.408, comma 0.913. Okay? So we're doing the opposite here. We're looking for the angle. How do you suppose we find that angle? You use the inverse of what? Sine and cosine. Do we need to use both? Do we need to use both? Okay. Well, if we use both, okay, we know this first coordinate is cosine theta, second part of the coordinate is sine theta. So yes, we are going to take the inverse. So we'll take the cosine inverse of 0.408, and we get what? So we'll get about 65.9, okay? Now realize that this theta, this angle, is going to be the same for whether you use cosine or sine. So you really don't have to do the sine inverse of 0.913. It should give you the same number, okay? I mean, you can check it though. Do sine inverse of 0.913. Do the sine inverse of 0.913. Do you get about 65.9? So it's the same thing. So you can do either one, okay? The main thing is to remember that cosine theta is your x-coordinate, sine theta is your y-coordinate when you're looking at a point amongst your unit circle. Now, there are a few things that you do need to realize because we were only looking at the first quadrant for those last two angles, for those last two examples, is that supplementary angles, okay, ones that, supplementary added to equal 180 degrees, would apply to your second quadrant of your unit circle, okay? And so if you have a point that's on unit circle, one in the first quadrant, one in the second quadrant, and those two angles basically are supplementary angles, 150 plus 30 is 180. They basically lie in the same location, just in different quadrants, which means that the sine of alpha, the sine of one of your angles, okay, so let's say that this angle here is alpha, and then this one here is beta, is going to equal sine of beta, okay? Because all you did was just change locations in the quadrant, okay? Same distance still from the x-axis and from the y-axis, okay? And if you look in quadrants, the first quadrant and the second quadrant, the y value is always what?
They're always positive.
They're always positive, okay? So whatever the value here is in the first quadrant is going to be the same value over here, okay? However, cosine of alpha, whatever this angle is going to be negative cosine beta. Because in the second quadrant, the x-coordinate is what? It's negative, okay? In general, okay, all around for any angle theta, sine theta equals sine of 180 minus theta, okay? So whatever theta is, the sine values will equal each other. And then cosine theta equals negative cosine 180 degrees minus theta. Okay? Now you can always figure this out algebraically. You don't really have to memorize these set formulas. They're not really in your reference booklet. However, there will be a time where they might ask you, what's the sine of a particular angle? And you're like, well, I don't know that if I don't have my calculator, but they gave you one that was like corresponding to the first quadrant, and its angles in the second quadrant, for example. You just have to know that the sines are going to be the same value, and then the cosines are going to be opposites of each other. The following properties are also true when you're looking at an angle of theta, which is within the unit circle, is that because, again, you're able to create a right triangle inside of a unit circle. Instead of saying, a squared plus b squared equals c squared, well, a and b represent sine and cosine. They're the legs of the right triangle. So you can also say that sine squared theta plus cosine squared theta equals 1. That's known as your Pythagorean identity. And also that tangent, instead of saying opposite over adjacent, well, the opposite side in your right triangle within your unit circle is sine. The adjacent side is cosine, so tangent theta equals sine theta over cosine theta. And then lastly, for any line, y equals mx, for which forms an angle of theta with the x-axis. So if you have a line that forms an angle with the x-axis, the value of m, the gradient, the slope, is always tangent theta. So sine over cosine. All right, so we're going to take a look at this example. We're going to find the gradient of the line shown. We're going to find the gradient of the line shown. Okay, this goes over pretty much the third property when you're looking at triangles inside again, it said that what? The m, the gradient, the slope of the line is what? How do you find it? It's the tangent of theta. Okay? So you have to be careful. Why do you think I say you have to be careful? It's in the second quadrant. Okay? That slope should be what? What type of number? Say it. It should be a negative number. Okay? So, said it is tangent of theta. Okay? If you do tangent of 60 degrees, what do you get? Say again. 1.73. But this basically says that this is a positive slope, not a negative. Okay? So, I say be careful because this 60 degrees is not coming from your positive x-axis going counterclockwise. It's coming from your negative x-axis going clockwise. Okay? So, whenever you're trying to either determine slopes of lines or you're trying to figure out angles within a coordinate plane or anything like that, you always start from your positive x-axis going counterclockwise until you reach that respective line. Okay? Otherwise, you'll have to remember that, okay, well, it's not supposed to be positive, it's supposed to be negative because it's a line that's going down. Or you can figure out that your actual theta is what number? 1. It's coming from your positive x-axis going counterclockwise. So when you do the tangent of 120, you'll actually get your actual slope, not having to worry about remembering anything. Type in tangent of 120. You get a negative number. And what number is that? Okay? Like I said, all you have to do is honestly remember that, hey, it is supposed to be negative. All I have to do is change that. However, a lot of you guys don't go back and double check your work. And there's a point right there. Right? Because it was coming, like, it's basically this way around. So yeah, 300 is. Questions? All right. Sine rule. Okay? This is used when you are trying to determine the side lengths and angles of non-right triangles. Okay? You have sine rule, you also have cosine rule. What's the difference? Well, sine rule is used if you know the size of at least one angle and its opposite side and one other measurement. That other measurement can be the length of the side or the size of the angle. Okay? So those situations, you're looking at either like angle, side, all right? Or you're looking at side, angle. Okay, these are like, if you want to kind of take it back to like your geometry days, what that might look like. You basically know 2 angles in a non-included side or 2 sides in a non-included angle. That's when you would use the sine rule. Okay, so for any triangle ABC, where A is the length of the side opposite of angle A, B is the length opposite of angle B, and C is the side opposite of angle C, you have your sine rule. And yes, there are basically 2 different ways that you can write it. Honestly, you'll get the same answer whether you put the angles on the top or if you put the angles on the bottom. Now, hopefully you recall this from your previous class. Basically, sine rule are proportions. Okay, you're basically comparing the angle opposite of its respective side length to the other ones. Okay, so when you're trying to use this to solve your problems, you're not going to use all 3 ratios at the same time. You're going to use 2. You're going to use A and B, or B and C, or A and C. Okay, regardless, you're going to be setting up this proportion. If you are trying to find either lowercase a, lowercase b, or lowercase c, that clearly means you're looking for a what? A side. If you're looking for capital A, capital B, or capital C, that means you're looking for a what? And remember, whenever you are trying to find angles, you use the what? You're using the inverse, okay? So we're going to look at a few examples. Well, not a few, a couple. No, not a couple, several, that's what I'm going to say. We're going to look at several examples of sine rule. do on your own. I'll try back into this. One other concept that goes along with sine. Ready to go? Here we go. We're going to find the missing angles and sides of this triangle. This triangle here is given to us. Obviously, it could have said to solve the triangle. If it ever says solve the triangle, that means find its missing angles and sides that are already given to you. Okay? So this also means solve the triangle. All right. So hopefully you see that this is one of the situations where you use sine rule. This is this situation of side angle. Okay, you have two sides and a non-included angle. Non-included basically means that it's not the angle that the two sides that you know form. Okay, that would be angle C if it was the included angle. You could have had A or B given to you. All right, but basically you see you have angle A, you also have side A, you have side B, but you don't have anything else. What do you think would be the easiest thing to find first? Angle B, because you know A, you know one part of B, but you don't know the other part of B. So we're going to use the formula, we're going to set it up. And honestly, like I said, it doesn't matter whether you put your angles on the top or the angles on the bottom. You know, left side or right side of that formula from the other page. It still works. So, to find angle B, we're going to set it up. We're going to do sine of angle A, which is 98 degrees, divided by side A, which is 12, equals the sine of angle B, divided by side B. You set up the proportion, like so. All right? Some people might want to skip this step and go straight to the answer because they can recognize that, hey, it's sine. I already know that I'm going to do this, this, and that. I have my answer. However, for your method points, for your accuracy points and things like that, just in case, it's always good to write this down. Now let's solve this. How do you solve for angle B? 9.4 times the sine of 98 equals 12 sine B. You cross multiply. Okay? This is the line that you would get regardless whether you put your angles at the top or the angles at the bottom. Okay? How do I solve for B? You divide 12 by both sides. And then the last step would be to what? Take the inverse of sine, okay? I always like to write out this step just in case, because a lot of times they're looking for this point as well, this accuracy, knowing that, so the grader knows that you're taking the inverse. They know you know to take the inverse, because just in case you type it in wrong, you type cosine inverse for whatever reason, you get a completely different number. Or if you're in radian mode, you're going to get a completely different answer. What do you get when you take the inverse of this? 50.87, which would be 50.9 centimeters. Nope, not centimeters. This is an angle. Degrees. My mistake. Questions on that? For the ones who didn't have any last year. So, now to find what? Where can we go from here? Angle C would be the best one. Say what now, Elizabeth? What you say?
I was adding them and then subtracting.
Yes, there's 180 degrees in the triangle, so why not add the 2 and subtract it from 180? And I mean, hey, guys, you have the full decimal already in your calculator, so why not just add 98, 180 minus that answer, or 180 minus whatever. What do you get? What's angle C? 31.1 degrees. Okay? You still have that long decimal sitting in your calculator, correct? The reason why I keep referencing this is because since you're trying to find everything else and you're using a previous answer, why not just keep that long decimal in your calculator and continue to work with it all the way down? Okay? So, now to find side C, we have angle C, so we can set it up. How do you want to set it up? Yes, use A. So that'd be sine of 98 over 12 equals the sine of the answer we still have in our calculator. So 31.1 over C. Cross multiply, we'll have 12 sine 31 and the rest equals C sine 98. What are we going to do? And if you write it out, then you won't have to worry about like trying to continue everything down from your calculator or going back up to find it. Because right now all you have to do is type in 12 sine, second answer, divided by sine 98. It's still sitting there in your calculator. And that'll give you side C, which is 6.26 centimeters, about. No, kind of all over the place. That's why you see the colors. This is the one you're going to do on your own. This next one. Yes. Find your missing angles and side in this triangle. Sides. Missing angle and side. But I want you to round it to 2 decimal places. Okay? You're rounding your answers to 2 decimal places.
Yeah, I know.
All right. What should we do here to find our missing sides and angle? We can find C.
You already can add the 2 angles and get angle A.
Either way, okay? I mean, then we'll still need angle A. So let's find A first. How'd you find A? And what you guys get for angle A? 64. Very good. Okay? Doesn't matter.
Do C.
Okay? Equals over C. Doesn't matter whether you have the other one first, you know, the fraction basically flipped. That's totally cool. Okay? So from here, what do? Cross multiply, so you have 40.5 sine of 39 equals C sine of 77. And what will you do? You will divide by what? Sine of 77. You got to take the whole thing. And you got what for C? 26.16 because we were rounding to 2 decimal places. Don't forget about your units. How you set it up to find A? And then? And it's a similar process, right? You cross multiply. And then you what? Divide by sine of 77. This right here is your exact value. Okay, I will always write that out so that way you guys can see that. It's gonna happen for you all as well. What you guys get for A? 37.36 centimeters. Okay. Now do realize, guys, that once you find these values, kind of just double check to make sure it makes sense. The largest angle should be across from the longest side. Okay? Largest angle should be across from the longest side. Hold on, I'm recording.
Oh, you're recording.
Yeah. Alright, you guys, so let's do this one real quick. Alright, we have a ship. The ship is sailing due north. Okay? So no matter what, this ship is continuing to go north. Okay? It's not changing direction or anything like that. Okay? I think you'll plug something.
Hey, I still frozen.
No, I took the frozen off.